Hey guys, in this tutorial we're going to look at how to create something like this, but our main priority in this is going to be using and understanding the graph mapper and how we can use it to drive values and functions. So we're going to make a new document, and I'm going to start by dropping down the graph mapper. So the graph mapper is found in the input tab. Graph mapper, there it is. And in order to run the graph mapper, we need a list of values, or you could just use a value, but I'm going to grab a list of values. So we're going to grab a domain, and we're also going to grab a range component. Oop, there it is. And so our domain by default is 0 to 1, so actually we might just leave that, so we will leave the domain component for a bit later on. And we'll grab an integer slider. And I'll maybe give this a maximum value of 100, plug it all in, plug that into my graph mapper, and I'll give it maybe just 7 steps for now. So now what do we do with the graph mapper? As you can see at the moment it's doing nothing. It's basically just going to spit out exactly what we plugged into it. But what we can do is if we right click on it, we get these graph types. And so maybe I want to try, let's just try a Bezier graph for now. And so what this is doing is the graph mapper exists between a 0 to 1 space in the x direction and the y direction. So when you plug in a list of values, those are the values it reads in the x direction, and then it spits out all your equivalent y values. So if we look at this list, each of these red lines mark the point at which, the number which we're going to be returning. So there is a red line at 0, there's also one at the end, and this point over here is 0.038 in the y, this is 0.16698, 0.42, and so on and so forth. And as we increase these steps, you can see our red lines change, and beyond a certain point they just completely fade away. But don't worry, they're still there. Alright, so we're going to use this, we're going to delete these panels, and we're going to use this to try and drive some data. So I'm going to make another copy of my range component, and I'm going to plug a domain into it. Actually, no, I still don't need a domain, because I'll show you another trick. What we can do, let's say we want a domain between 0 and 100. All we need to do is just plug one slider in, and if we plug that into our domain, it'll automatically assume we want to create a domain between 0 and that number. Really handy trick. And so now we're going to construct some points on the other side. So my x value will be this range here, and my y value will be these here. Now you'll notice a very subtle change, because what it's doing is it's spitting out a value between 0 and 1, which is almost negligible. So I'm just going to grab a multiplication component, and I'll grab another slider, drop that down, increase my max value to maybe 100, plug that in, and then when I plug that into my y, you should notice a much more drastic change. And as we see, if we move these points of the graph mapper around, the points in our Rhino space will update automatically as well. Now we can change this to any kind of graph type we want. Maybe we want a parabola, or maybe we want a sine. Now this is very similar to what we did in the tutorial where we looked at sine functions, but basically this is just a more graphical way to do it if the formula method is a bit too much for you. We can just plug this in and very easily edit and see the result as we want. You can see it all updating absolutely live, which is fantastic. Now we could, let's try something else. We could create a grid of points by grafting our x, and then if we were to plug this into our z, there we go, now we're driving this entire grid, which is really neat. And so just for visualization purposes, I'll pop out a surface from points component. I'll flatten my list of points, and our U value is going to be our number of steps plus 1, as you may have guessed if you've watched some of my previous tutorials. So we'll just change this to U, just so I've got my convention all right, and we'll plug that into here. And there we go, now I can turn these points off. Alright, now we could take this a step further, and let's say we wanted this graph to control both directions of our elevation. What we'd need to do, okay, we need to change this setup a little bit. Instead of grafting this function here, what we're going to do is we're going to use a cross-reference. So we're going to cross-reference this range on itself, and those will be our x and y. Oop, so silly me, I forgot to ungraft that. Let me just undo that. Release the solver, and now I'm also going to cross-reference this graph mapper on itself. Now, what do we do with these inputs? It's basically it's just going to create a two-dimensional matrix out of this. So what we need to do is we need to multiply these results by themselves, and we also need to plug it back into our amplitude. And so there we go. Now we can control this surface in two directions. Once again, we can change this to anything we want. I quite like the Bezier tool. Also, this is just a personal preference, but I find using the mesh from points component, let's see, where did it go? Mesh from points. My U and V values are exactly the same. I prefer to use the mesh from points component just because we can visualize all the mesh edges along here. It makes it just a bit easier to understand what's going on exactly. Of course, anytime I actually want to bake it out, I would bake out the NURB surface. Just because, I don't know if I've touched on this before, but meshes are good for previewing geometry, but what you'll notice is that they rely on a bit more resolution. So when we're down all the way down to 3 here, 3 divisions, we get this very boxy, sort of hard-edged surface where you can really tell all the mesh edges apart. Whereas this NURB surface will remain completely continuous and smooth. The NURB surface will always have completely smooth curvature, whereas a mesh will never have smooth curvature. But if you bump up the face count enough, you can get it to fool you into thinking it's quite smooth, as you can see. Anyway, that was a bit of a tangent. I'll just keep this on for visualization purposes. Another thing you should note, if you might be seeing your mesh like this, and you might be wondering what I'm talking about. In order to turn mesh edges on, just click in your in your Grasshopper canvas and hit Control M, or I think you can go to the Display tab and preview mesh edges here. Alright, anyway, back to the task at hand. Now what we could also do here is we could bring in a second graph mapper, and I could change that to maybe a sine. And so I'll plug that into my B. And now, as I edit this, I'll also bump up my steps. We're getting our Bezier curve controlling one direction of the surface, and this sine curve controlling the other direction of the surface. Now I might, for all intents and purposes, just change this to assign summation in both directions, just so we can create something a little more interesting. Maybe I'll do, oh, that's probably a bit much, bump up my resolution a bit more, and this one, we'll do something like, oh, not quite, maybe something, okay, there we go, yeah, I'm happy with that. Alright, cool. Now next thing we're going to do is we're going to look at something we can do with this surface. A really cool component is the ISO trim component. If you've never come across the ISO trim component, I'll just bake this mesh out, or this surface out into Grasshopper, so we can do a little bit of an explanation of what it's going to do. So if you wanted only a section of this surface in Rhino, what you could do is you could trim it, not trim it, you could split it, and you get this split by ISO curve option. And so an ISO curve is basically a curve along the direction of along one direction of the surface, which is along a consistent parameter. So this might be 0.1 in the U, this might be 0.2, 0.5, actually, and so if I were to split this here somewhere, what you'll get is two separate surfaces split by that ISO curve. Alright, pretty simple. Now we can do the exact same thing with the subsurface component. What we need to get it to work is we need the surface, and we also need a domain, but it's a bit different to a usual domain. Normally we've just used these one-dimensional domains, but because we're working with a surface, we need a square domain, a two-dimensional domain. And so what we're going to do is we're going to grab this divide domain squared component. And so it asks for the base domain, and interestingly enough, our base domain can in fact be a surface. And then our U and V values are just adjusted by a slider, and I'll give that a maximum value of 20, set it to integers, okay, plug it in, and this basically controls the amount of divisions we want on that surface. So if I plug this in now, you can see what we're going to get is 7 surfaces, 1, 2, 3, 4, 5, 6, 7 in both directions, and as I edit this, it updates accordingly. So now what we have is 4 completely separate surfaces as a result of our ISO trim. ISO trim just means trim by ISO curve. Alright, now we could, if we wanted, we could take this subsurface, or this ISO trim, and we could do another ISO trim, but we're going to do something a little bit different. For this one, instead of using the divide domain squared, we're going to construct a square domain. And you can do this one of two ways. You can either do it, whoops, it's the same component. You can either do it using two domain components, so we just plug these into here and set our minimum and maximum for each, or you can just plug those numbers into here. It does the exact same thing. So what I'm going to do is I'm going to grab a slider, I'm going to chuck it in, actually let me plug that one in there, and then we'll do the same for these two. And so maybe I want it from 0.16 to 0.1 in both directions. And so we'll plug that into our domain, and it's going to throw an error just because it's not understanding what we're wanting to do with the domain yet. So we're going to reparameterize the surface, and there we go. So basically what we are doing here is we're taking each of these surfaces that we created with the initial subsurface, and we're extracting just a smaller area of that surface. So I can use this to basically trim off as much or as little as I want in either direction. Now a real neat trick that we can do here is we could grab a expression, and we're going to make a real simple expression which is 1 minus x, and we'll plug that in, get rid of our y because we don't really need that, and we'll plug that into our u, and we'll do the same for our v. And so what we can do with this is we can control both sides of our trim so that we're getting a uniform shape in the middle. Pretty neat little trick. In fact, if we wanted, we could control this all from one single slider, so that we are just getting the absolute center of each and every single one of these little surfaces. There we go. Now, just to finish this off, we'll take all of these surfaces and we will project them. Here's what we've got to be aware, because there's 4 different project components. The one we want is to project an object onto a plane. So the object I want to project is each of these subsurfaces, and the plane is our world XY. That's absolutely fine. And so now we can just so now we've just dropped it down onto that plane. What we could do is we could loft these together. Now just watch what happens. Okay, I might just quickly turn these divisions down in case Grasshopper decided to crash when I do this next step. If we were to try and loft this, it's going to try and loft all of these surfaces together. And that's because what we need to do is we need to set up the data structure a little differently. So we're going to graft this, and off the bat it's not going to do anything just yet because we've only got one item in each of these lists. So we're going to plug in our projection as well, and so what it turns this list into is 9 lists of 2 items each. And well, that's what we want, to be honest. So it's really important to make sure your data structure is doing the right thing. Now we can go in and we can increase these divisions, and the last thing we need to do is we just need to join these up, because if we were to bake this loft out, it's only going to be the midsection, it's not going to be anything else. So I'm just going to use a brep join component, and good thing is these data structures will all still match up perfectly. So I'm going to start by plugging in the bottom of the shape, followed by the middle of the shape and the top of the shape. Then we'll turn these off, and if we bake these, you can now see these are all individual objects. And there we go. Now, if we go back to the beginning, we can see that this is all pipelining through here. So this is going to be really slow at the moment because there's a lot of calculation that it's doing. But we can control all of this at any which stage we want. We could do the same with this graph mapper. We could change our elevation to whatever we want. We could change the size of this grid. And we could go back in and let me just replug these values in here. We could go and trim this to whatever size we want. So maybe I only want that much in the V direction and that much in the U direction. And maybe I want a whole lot of these. And then I can just bake those out. And there we go. A whole lot of weird, maybe like a weird sort of monolithic neighborhood of some sort. There we go. Hope it was a good tutorial.